Hello, good evening. This is Inyasura Singh. This is Inyasura Singh calling from Bharat, India. Sorry, this gentleman is fucking disturbing. Why are you disturbing, you little idiots? Why are you disturbing? Well, I'll let him disturb, I don't care. That's Inyasura Singh calling from Bharat, India. This is one screen share file regarding subject written there, because this is an introduction to properties and utilization in TechOpen. This is title of this file, and when I move on this file, I find, see, when I move on this file, uh, cancel, okay. When I move this file, this is Montmorillonite, an introduction to properties and utilization. This file shall be attached to other videos, and this is here. You can say I just belong of this. This is an open access file here. It's written is regarding this, and there is now this is a www.intechopen.com books etc. This is a reference one. And what about this file is regarding soil. There's an introduction here. It's the abstract is clay mineral. Clay mineral is an important material available in nature. With an increasing understanding of clay structure, Montmorillonite relies viable for an enhanced performance in a variety of materials and products in area of catalysis, food and food, additive antibacterial functions, polymer sorbent. Significant development in use and application of Montmorillonite is seen in recent time. This chapter provides an overview of Montmorillonite structure and properties, and particularly discusses its recent utilization in important materials. Montmorillonite is introduced in terms of its natural sources, chemical structure, physical and chemical properties, and functional utilization. Important physical and chemical properties are summarized as particle and high layer structure, molecular structure, and cation exchange, affect barrier property and water absorption. This is followed by important functional utilization of Montmorillonite based on effects of its chemical structure. Important functional utilization of Montmorillonite includes food additives for health and stamina, for antibacterial activity against the tooth and gum decay, as absorbent for non-ionic, anionic, and anionic and cationic dyes, and used as catalyst in can say organic synthesis. Environment concerns to date do not indicate adversity for particle used, and the additive studies will be useful only for fully based on Montmorillonite structure. ये Montmorillonite जो होता है मिट्टी के अंदर, चिकनी मिट्टी के अंदर, उसके बारे में मैं बात कर रहा हूँ. ये एक फाइल ऐसी है जो शेयर करेंगे दूसरे वीडियो के साथ. ये बेसिक वीडियो नहीं है ना, इंट्रोडक्शन इसका आता है. दिस चैप्टर 2 और 17 पेज इंट्रोडक्शन में है. Historical clay mineral has benefited human life, and long benefited human life and civilization. Being an integral part of Earth's history is older than the creation of man. Divine script Holy Quran confirmed that man was created using clay. This indicates that clay mineral was present before human life began on earth. Ancient Greek philosophy and culture consider clay an important component of life, and this is then another history. Technology, when technology was not at core of human civilization, clay mineral was used an important form of material to form a variety of products. Its softness, plasticity, porosity, tangibility, pliability, and climatic adaptability, affordable cost, or viable characteristics recognize usefulness. Today, the nanotechnology is hallmark of scientific world. Can say contribution of clay mineral is significantly visible as highly useful fillers or additives in polymers for desired effects. Nanoclays based on Montmorillonite are currently used to modify and polymer performance. Science of clay was introduced since the prehistoric times. Ceramics used nanoparticles in antiquity. However, nanotechnology is novel scientific utilization of nanoparticles. Use of kaolite may be dated back 3rd century BC in China. Clay. Traditional name of kaolite is mixture of minerals generally containing kaolinite, quartz, mica, feldspar, illite and Montmorillonite. Historically, use of clay is known in architecture, industry and agriculture, and common characteristics of clay size is even 0.002 to 0.001, and that's in quartz, mica, feldspar, iron, aluminum oxide, and also it is it's it's also 0.004 mm in diameter also, and also less than 0.001 in diameter. Just to tell is this, there is a group, it's a kaolinite group, smactite group, illite group, then it is a chlorite group, and these are having various types of members in this minerals. So kaolinite is kaolinite, dictite, negrite, and dictite, negrite, and smactite is Montmorillonite, pyrophyllite, talc, vermiculite, etc. And I'm not giving chemical composition here, we'll take in video. Now it's giving major groups of clay minerals. Kaolinite group has 3 members, including kaolinite, dacite, and negrite. Formula for kaolinite group is Al2Si2O5OH4. Illite group is represented by mineral illite, only common clay, and chlorite group is relatively larger. Now kaolinite, so clay minerals groups kaolinite, 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 Montmorillonite, smactite, illite, vermiculite, and chlorite. Sheet except for layers, sheet structure. There are sheet structures in this, and it is natural resources of Montmorillonite are present in various parts of the world. And earliest discovery of Montmorillonite was indicated in 1847 in Montmorillonite in Guyana province of Hawaii. Use of Montmorillonite for medical and all these purposes was there. And it is that names used for Montmorillonite are known in different languages. So bentonite is there. Bentonite, an important rock of clay found in nature. Bentonite is rock. It's an important source of Montmorillonite in nature. Montmorillonite we take out from bentonite. It's a rock forming highly colloidal and plastic clay mineral, mainly composed of Montmorillonite. And then we have bentonite varieties are the result of useful interchemical composition and permeability, chemical and physical property, range of property, include rheology, sorbent effects, elasticity and lubricity. I can say high dry bonding strength, etc. And when you go on further pages, you'll find similar natural bentonite parts of indistinguishable. We have kaolinite clay from kaolin clay minerals under scanning electron microscope. However, main difference indicated was thickness, sodium or potassium salt or bentonite exposed like that. And then we have clay mineral based on bentonite, and bentonite which mainly contains Montmorillonite. So this contains a Montmorillonite structure. The structure is Montmorillonite particles generally perceivable. In this we have one diagram. You can see this figure, this photo is on page 4. Each layer is composed of 2 type of structural sheets, octahedral and tetrahedral. Tetrahedral sheet is composed of silicon oxygen tetrahedral and silicon and linked to neighboring tetrahedral by sharing 3 corners, resulting in hexagonal network. Remaining 4th corner of tetrahedron forms a part. The adjacent octahedral sheets. Octahedral sheet is usually composed of aluminum or magnesium in 6-fold coordination with oxygen. From tetrahedral sheet and with hydroxyl 2 sheets together form layers. So this is photo here of that molecular structure this is, and van der Waals bond is there in between this. Then you go to first property of this Montmorillonite property is very theoretical formula is there, and which is shown in this paper, and then we can say that is considered about property. Density 2 to 3 gram per centimeter cube. Crystal system monoclinic. Hardness is 1 to 2 on Mohs scale. Soft causes fine grain occurrence and fracture in regular uneven. Cleavage is perfect and luster earthy dull. Transparency, translucent color is white, buff, yellow, green, rarely pale, etc. And in table 3, important natural physical properties of Montmorillonite. And this is variation of chemical formula of Montmorillonite is possible, resulting from manifold modifiable structures. And then you can see chemical formula is given there. Oxide composition comprises silicon and aluminum oxide. The oxide composition which is silicon, aluminum oxide. Elementary molecular structure based on unit comprising silica tetrahedra, and layer structure is influenced by presence of charge in tetrahedra. So I'm not speaking all this. The Montmorillonite is nanoclay, which means Montmorillonite in nanoclay. This is available in nanoclay. and basic raw material used in producing nanoclay. Chemically, it can be described as hydrated sodium, calcium, aluminum, magnesium, silicate hydroxide, and it's a very long formula. NaCH 0.33, AlMg2, Si4O4, O10, OH2, 2N2H, etc. You see yourself, this is given there in this page. Then clay polymer system. Clay nanoparticle can be intercalated or exfoliated, where clay crystal is used in nanoparticle. It can be referenced as incalculated clay, etc. You can see this file completely. Movement is there on my hand. I'm moving this file both ways. And then lateral length and breadth of particle can range from this. You can see this complete details are here, and you can go through that. Let us say another deal is there. You can read that. Stop this and read it. I cannot speak anything everything here. I'll just explain on other file of main video. It's just for reference purpose. You can say it is Montmorillonite, nanoclay Montmorillonite is there. Clay polymer system, length and breadth. The particles and the nanoclays are available. Containing 98% Montmorillonite, and Montmorillonite is required to be surface modified. And you can see this and 40. Then Montmorillonite nanoclay is indicated as the drag carrier system, and it's additive. Montmorillonite for application system can be through utilization, atomic time, and all that. It's like this, and you can say review this. So this is also, I'm just trying to show you file here because I cannot show you when I do main video. So at least you know what is there in this file. There's no way I can explain to you everything here in this small video. This is just attachment, and you can, when you open this, you download this functional properties, cation exchange properties, and cation is also detailed well. This complete chemical composition is here, and also say electrical conductivity. About that details are given. Electrical conductivity, clay particles are porous materials, and they store charges of electrical due to water presence there. This is given here in complete, which I have already taken video. Water, air, water, saline water may be present in pore. When pore fluid is of low conductivity, air, water, full conductivity off. Full conductivity, that you consider, and then you can say there is then higher content of clay particles with 2 to 1 structure present normalized sample produces an increased bulk electrical. You can read this whole theory written of how this clay impacts on this. Silt, clay, content, pore fluid, clay type, same thing, water, etc. And water saturation analysis, complete drop thing. Then you can say distribution of electrical ions around clay pore is called membrane polarization, the negative are very interesting. And you can say there are so many, this is about heat resistance is also there. The heat resistance, and this is about clay, electrical conductivity, then it is heat resistance. Yes, how much heat resistance, thermalized is good heat resistant, and insulator and heat resistant effect is additive. So it's that one. Then variation and extension of the heat effects. Well, we can see then another page, water absorption is there, heat resistance facilities are there, heat resistance you can see here completely, and then you can say this file, syntax, thermal barriers, polymer, and this, complete, values are given, and then therefore increased thermal stability, question is there, you can see that one, thermal stability, and then you can say water absorption is, you can see all this horizontally improve this brush file. What is a longitudinal page? And then Others are clearly then Montmorillonite is a 2:1 clay mineral. That's 2 tetrahedral sheets separated by Montmorillonite platelets, and this all this file is available here. Complete details are available like this, and also I put some on some website which reference available on you know on this video. That video is a detailed one as a functional utilization, as functional utilization of this. So you can just go through these pages if you want to get something, and all these medicals, so possibly they help in good growth. And then resistant to decay, also resistant to rain, so you can say then there are so many other issues, drug delivery system, and I cannot read it word by word in this because this is very short video. Which of some dry stuff. Then thermodynamic study of methane blue absorption Montmorillonite, that it processes endothermic, determines enthalpic. Means we have to see all these applications which are given in this. That's what you can say. I think let me say it's now let me say, and this goes like this. I think it's raining outside. Let me go and see it. I have to do this video for that. It's raining outside maybe. So Montmorillonite is a biopolymer, and you can see this file. This is just for information here. This file is available here. So Montmorillonite, and this is a complete system. And this is orientation. You can see this. So it's safe. You can use this file. Complete details are here. It is for information to you. And then I think environment conservation. This is your organization of this Montmorillonite, green chemistry and waste the control and reduce chemical waste. And this is given here. So you can use this one and all that. This is green chemistry. Then further details of this are given in this. How it can be used, where it can be used, how can you benefit from this, and how is using it like this. You can say natural clay particles and how these can material like dust. So I think when this chapter is over, we come to something else.